Okay, so now one more thing, we have got the node, we have got the time, everything. The packet is the only thing that is remaining. Now we are using these functions, but before using these functions, we should make sure that corresponding header files are included. Okay, suppose we are using node speed here. So node speed variable is defined in mobile node.h. Okay, so what we will have to do in this file, which we are using, mobile node.h should be there. It should be included, even if in this file or its corresponding .h file. Here mobile node.h should be included. If it is not included here it is included. No problem in that. If we remove this file and compile, then what we will get? We will not be getting the output. Okay, what output? We will not be getting the node speed or position like this. Why? Because it will provide an error that it is not defined in the scope. Okay. However, it may not give error because the corresponding mobile node.h file is defined in other files as well, whichever it is using. So it may be the case or may not be. But generally for safe side you should write. Okay. Now for that timer, we use this timer scheduler instance clock. Scheduler is the class. So we should always use a header file. Now the one more thing is there. What? Packet. Packet we have not talked about yet. So similarly, for as we are using index or speed or anything, the properties of nodes, properties of packets are also there. How we get those properties? In every packet, whenever it is formulated, means whenever it is designed, what happens? Some properties of these packets are defined. So whenever we receive a packet or we want to transmit a packet, then we define some properties of that packet. Okay. Sorry, or receive a packet, we have to extract the properties of that packet. Suppose a receiver has received a packet, but it does not know the sender of that packet. Okay, so what it will do? It will be in confusion whether to receive this packet or not. It may be a malicious node, something like that. So what it can do? It can access the property of packet, the header of packet, and from which destination for which destination it is coming and from which transmitter it is coming, and what are other properties, what is the size of packet, these things it can know. Now, how to know the properties of a packet? This is this simple line. Here I will cut it from here, paste it here. Okay, whenever you want to know the properties, some basic properties, common properties of a packet, you just have to write this line. Simple. What is the difference? This P is a variable and this CH is a variable. HDR CMN means it is a common header, CH is an object of it, and HDR CMN P it is a function. So don't go into deep in that. I will tell you, however. But whenever you want to get some information about a packet, you will have to copy and paste this line always. Okay. Suppose here why P is written here? Because the packet P is received here. If we change the name, suppose P1, we will have to change it to P1 here as well. Okay, otherwise there will be an error. Now, what properties we can get from common header. Let us see what properties can be there. I told you it is in packet.h file. So we will see what is there in packet.h file. Okay, here directly it is open. Common header is open. So what is here? What are the properties written in this common header? It is direction, enum function. If you know, it is okay. If you don't know, let me tell you. It means for a particular set of characters, it assigns a numerical. Okay, numeric integer, you can say. For down, it is assigning -1, none 0, up 1. Okay, don't worry about it. What are the properties written in common header? It is whether packet is going down or going up or nothing is happening to it. Going down means in the layered architecture, if it is going down means from network layer to MAC layer to physical layer, it is going like this, or it is going up. Or you can say if the packet is getting transmitted or getting received, you can say like this. If it is going down means it is getting transmitted. It is going up means it is getting received. Okay. Now packet type, some packet types may be there. Okay, it is another structure, so don't worry about it for now. Integer size. What is the size of the packet? Unique ID of the packet. Error flag. Error bit count. How many bits are corrupted? FEC size. TS, time stamp. I phase, interface, direction. That is the same thing, up, down. Okay. Many things are there. Don't worry about everything. NS address T. Previous hop. What is the previous hop of the packet? Means the previous sender of this packet. And what is the next hop? Means the next receiver of this packet. Okay. Address type. What is the address type? What is the last hop? All of these variables even I don't know. Okay. Some variables which are used commonly that I know, like previous hop, next hop, size, unique ID. These things are commonly used. Okay. Now some more things are there. Transmission time. How much transmission time is taken to transmit this packet. Okay, these things are here. So let us see basic properties of a packet. Let us see how we can get. Now go back to our main code. Here in CH, common header, we have written in this CH variable. So suppose we want to get any variable. So we will write printf the size of the packet is equal to, or remove equal to, percentage %d. Since size is always an integer in bytes actually, so what it will be? ch. Ch is an object, like node was an object, ch is an object. Ch and size underscore. Okay. Why this is size underscore? Because in packet.h size underscore is there. Okay. So let us see whether we can get it directly like this or not. /n I will write. So before that we will have to recompile it. Okay, now let us see what we get after running it. Okay, we are getting here size of the packet is 48. Okay, size of the packet is 48. Why only 48? If we see in WLAN1.tcl, what is the size of the packet we provided? If you remember, the size of the packet is, I think, around 500 bytes. Let us check it. Okay, it is TCP. Okay, so in the data rate is defined here. So no problem. Forget it. Don't go into that much detail. I will tell you how you can find. Size of the packet is 48. So 48 is generally not a size of a packet. 48 bytes is very, very small. So you check more. Check more. If you get something else than 48, you are getting 40 here. Here, see here. You are getting what? 1040. So the size of the packet is 1048 bytes. Okay, 1040 bytes. Like this. Sometimes 40 you are getting, sometimes 1040. Sometimes you will get something else like 48 you got. Here also you are getting 48. Why this is happening? This is due to different types of packets. Different types of packets means the packets may be, if you remember, the AODV packets were getting transmitted. 48 means it might be a control packet. Okay, either of AODV or something else. If any big packet, suppose 1040 size, it is the data packet. Okay, like this you can understand. Otherwise, by seeing the trace file, you can directly know the size of the different packets. Okay. So what I am trying to tell you is, you can get the packet properties here as well. Now let us see another properties, what is there. Unique ID. Okay, unique ID, UID if we want to see. So again we will print one more line. The unique ID of the packet is CH UID. Okay, so if you run it, we will have to make it again. If we run it, let us see what we get. Unit ID of packet is 0. Okay, 0 is why? Because those were control packets, I think, or something else. Wait a minute, let me check. Okay, here we are getting the unique ID of packet is 1052. Okay, here 1078, 1075. Okay, 105. So means different unique IDs. If we see at the beginning, the unique ID must be 1, but we cannot go that much up in the terminal. So unique ID is 645 as well, 640. It is continuously decreasing as we go up, and in the beginning it will go up to 0 or 1. Okay, if there are any control packets, the unique ID of packet is generally 0. Okay, I don't know the reason, there must be theory behind it. Okay, so it is like this. So unique ID of the packet is 707, like this we can get. So the packet unique ID we got, the packet size we got, and the most important thing that you can get from a packet is the source address. Okay, why source address? Because if you know the source address, you can get the properties of the node that is transmitting the packet. Okay, by using what? If you get the source address, suppose ID you got, you can write that value here. If you write that value here, all the properties of the sender node you can check. Okay, and based on that you can design your own protocol. Okay, now let us see how we can get the source. You can get the previous hop as well and next hop as well. The next hop is to which it is to be transmitted. But remember one thing, it provides for the immediate neighbor. If you know the theory, IP addresses are used for source to destination transfer and MAC addresses are used for immediate transfer. Okay, so but this is telling you what IP address of the forwarding hop is just previous node, not the initial one. Okay, how you can get the initial IP address? There is another file for that, that is called ip.h. Okay, in ip.h, source and destination are these variables define the ID of packet. Okay, so let us see how it defines. Okay, I have told you a lot of small things today. So if you have any doubt you can ask and I will provide you the recording, so you should learn from there as well. Okay. Now ip.h, how we can get the source address in ip.h, how you can get the, for common header you just simply wrote hdrcmnp, hdrcmnch, but in ip.h hdrip is there. So what you have to do, just copy and paste things. Now suppose I want to hdrip, I will define an object of it, suppose IP. Object I have defined is equals to, here hdrcmn is written, I will try to write hdrip of p. Let us see whether it works or not. And the source of the packet is, I will do what? IP src. Why IP src? IP is the object that I have defined here for IP header, and ip.h, in ip.h src underscore is used, but I will be getting some error. Why? Because it is not an integer. ns underscore addrt. Okay, this is another variable. Okay, this is not an integer. So let us see what happens if we run it. Okay, somebody has switched on his microphone. Mohammad Demri. Mr. Mohammad Demri, please switch off your microphone. Hello. I can mute him. So now okay, let us see what happens. I will save it and will try to run it. Let us see what error I got. Let us see what error I will get. Okay, there is no error. Sudo make install. Let us run it. Okay, here what we are getting, source of the packet is 79, 79, 79, 111, 111. Okay, so I think we are getting correct. 922, 915, 94, 2. Okay, we are getting correct, I think. So this is the correct thing. So I had a confusion that I may get one error, but error was not there, and the output I checked, it is within 149 value only, because the number of nodes I defined 150, 0 to 149, and the source packet, the source of the packet is below 150 only. So I can understand that it is correct. Okay. Now what you can do, now all the small things I think over. If I remember anything, I will tell you again. Now how to use these things. We have got the source address, we have got the ID of the packet, size of the packet, everything we have got. Okay. Now how we can use it? Speed of the node, everything we have got. Now suppose you want to make a cluster. Okay. I will give you a rough idea, but some more things we will have to incorporate in that if we design a good cluster algorithm. What we will have to do, we will have to check a particular node. Okay. And what are the nodes that are available in its neighborhood, okay, in its range. Okay, I did not tell you how to define the range of a node. Okay, I will tell you tomorrow, don't worry. The range of the node, very small things are there. I should have told you in the previous webinar only, but okay, I will tell you tomorrow. But let us suppose we want to design a cluster. What we will do? We will select one node and we will check the number of nodes in its vicinity. Okay. And we will, what we can do? We will check, means we can do clustering in a lot of ways. Suppose in regional clustering, if we select one particular node, all the neighbors in its vicinity or in its range are incorporated in a cluster with it, and that particular node becomes cluster head because it is in the center. Okay, like this we can design a protocol. It is very simple. Okay, this is a very rough example, and now clusters are not defined in this way. There are many different algorithms. Okay, so now let us see how we can design this thing. Okay, so this is the last thing I will be covering today. I have taken this example randomly so that you can understand how you can think if you want to design from beginning. First thing is, I told you will have to select a node and you will have to check all the nodes in its range. For now, suppose I am assuming that the range is 50 meter. Okay. Now, first we will be selecting a particular node. We have how many nodes? 0 to 148. Total 149. So total 150 nodes are there. I will select node number 0 first. Okay. I will check all the nodes in its range. How I will check and how I will select the node? For selecting a particular node, we just simply write. Okay, I will comment all these things now. Okay, this line we will have to write here. Now, how we will select a node? Suppose node ID 0, I want to search. So just copy this line. Now you know the importance of copy paste. Just copy this line, write 0 here. So this will do what? In the variable node, all the properties of node 0 will reflect. Okay. Now what you will do? Node X. Okay, the x-axis, x coordinate of node and y coordinate of node you will get like this. Means I am just writing. You will have to incorporate it in some variable. Double x-axis. Suppose small x is equals to this, and double small y is equals to something. Now, how you will check how many nodes are in its vicinity, means or in its range? I have told you, assume the range is 50 meter. Now what you can do? You will have to check the coordinates of node 0 that you have checked from these two commands and coordinates of all other nodes. Okay, as much nodes are present in your code. Okay, so now suppose you have taken node number 1. So the distance of node number 0 to 1 you will have to check whether it is less than 50 or not. Suppose it is less than 50, then you will incorporate it in a cluster. Okay, but let us check the distance first. Okay, for getting the distance between 0 and 1, what you will have to do? You will have to get the coordinates of node number 1 as well. We have got the node coordinates of node 0 only. Now we will have to get the coordinates of node number 1 as well. How you will get? Just copy it and paste. Write 1 here. Copy it and paste it. Now, but you will have to change this variable. Node 1, node 1, node 1. And change this variable as well, x1, y. Now, what we will have to do? Simple. We will have to check distance. So, if. Now, what is the, how we check the distance? What is the mathematical formula of it? If you know, it is simple. What? Under root x minus x1 square plus y minus y1 square. Okay. So, this is how we can get the distance. So, the same formula we will be using here also. But stop, wait for some time. We will be getting the distance of between node and node 1, means node ID 0 and 1. But what about node ID 2, node ID 3, node ID 4? So we will have to write these lines again and again. So it is not a good idea to write this much amount of lines. For that purpose, we just simply write a for loop. For int I is equals to 0, I is less than 150, because we know total 150 are there. This thing also we can change. I will tell you I plus plus. Just write everything in this line. Okay. Now what you will have to do? Node ID 0. This much. Suppose from node ID 0 we are getting. So double x. This also I will put it before the code, before the loop. path from source to destination. Okay, you can find the path from source to destination. Okay, but there are many ways of it. It is generally the work of a routing protocol to find the path from source to destination. So you will have to search in the routing protocol. But if you want to use it in the source code, then you will have to search in the source code. Otherwise, if you just want to know what is the path between source to destination and you don't have to use it in your source code, what you can do for simplicity, whenever a packet ID is received, okay, whenever a packet ID is received, you can print that particular packet ID and the current node. Suppose you want to search suppose packet ID 15 from which source to which destination it traveled. What you can do? You can print a command in receive function. Okay, in receive function you will have to print a command that the packet ID this is received at this node. Okay, and it has come from this node, because when you receive a packet, I told you the answer of your question is in this, whatever I taught today, in that thing only. What it is, you can get the source of the packet as well as the current node. Okay, so if you get the source and current node, then you can know the path. Okay, for current node, then this current node will transmit it to some point, then again at which node the packet is received, then you can know it. Okay, like this you can know the path from source to destination. But if you want to change source code regarding this path, means suppose before transmission of data, you want to check what is the path from source to destination. For that purpose, routing protocols are used. Suppose a very simple routing protocol is AODV. In AODV, a path is formed before transmission of data. So how you can do? So you can learn. The path is first formed. It is the function of that particular code. It will first check the path, then it will transmit the data. So in AODV file, you can get that path. Okay. You will have to search somewhat, then you will be able to search it. How the paths are defined, in which variable it is written, like this you can know. Okay. Okay, Mr. Uday, I think, is it okay? Or you want some more clarification? Okay. Okay, so now here for node 0 only, I am checking how many neighbors are present in its vicinity. So I will change this I from 0 to 150. So here I will write I. This value will come into node 1, and so x1 and y1 represents the value of this node. Suppose node 0 first, then 1, then 2, then 3, like this. And x and y represents the value of node 0 only. What we will write here? If sqrt square root of x1 minus x minus x1 multiplied by x minus x1 plus y minus y1 multiplied by y minus y1. Now what happens here? This is a simple function, under root x1 x minus x1 square plus y minus y1 square. So if it is like this, then what we will do? We will print node, particular node is in the range of node 0, and we will have to provide that this distance should be less than 50. Okay, suppose for now we are assuming 50 meter is distance. So if distance is less than 50, what we can do? We will print that this node is in the range of node 0. Okay, this is as simple as it is. Let us see how it runs. It will provide the result of is how many nodes are in the vicinity of node 0. So sudo make okay, this is it. Okay, some error is coming. Error means it is not an error. Some garbage value is being printed. Okay, sorry, we have not written anything here. That is why. Okay, so node 1. We cannot write node 1 only. Why? Because node 1 is a complete, is a object. So we write only I here, because I represents the current ID of the node. Okay, so just make it install it. It is not increasing, I think. It is always showing node 0 is in range of node 0. Let us see what the problem is. Okay, maybe node is in the vicinity of 50 meters. So let us change it to 500 meter. Let us see what happens. Maybe since it is a large topology of 5000 cross 5000 meters, and we are using only 150 nodes, there might not be any node present in its vicinity. So let us run it again. So yes, now we have increased the range to 500 meter. Now we can see node 72 is in range of node 0. Node 67 is in range of node 0. So only 2 or 3 nodes we can see. 1, 67 and 72. 0 is this node itself. Now 112 is also coming here. Since the nodes are moving due to different time, at different time different nodes may be in the neighborhood of each other. Okay, so you can see like this. Okay, now if you want to check the time also, what you can do, at time percentage f, and what you will have to write to check time, this one I told you. So you can write this one here, comma I. So if you run it, you will get to know at what time which node is near to node 0. Okay, so corresponding time also we are getting. At this time this node is in the range of this. Okay, many times it is printing. Why it is printing many times? Because whenever the send data function is getting called, then this process is happening. Okay, so it is not necessary that we put it in the send data function only. I have just shown it here to you. You can write it anywhere, but make sure it is a function that is being called by the simulator. Okay.